Welcome back to my channel Maths and Olympiad. In this video, I am going to take up a very interesting and challenging logarithmic equation question from Maths Olympiad, which says 10 raised to the power log x to base 2 plus 10 raised to the power log x square to base 2 equal to 10 raised to the power log x cube to base 2. We have to find the value of x. So let's start by writing the solution. Now I will use one of the properties of common logarithm, which says a raised to the power log b to base c equal to b raised to the power log a to base c. Here base and the exponent will get interchanged. By applying this law here, we can write x raised to the power log 10 to base 2 plus x square raised to the power log 10 to base 2 equal to x cube raised to the power log 10 to base 2. Now I will use an exponential law, which says a raised to the power m whole raised to the power n equal to a raised to the power n whole raised to the power m. So by applying this law, we can write x raised to the power log 10 to base 2 whole raised to the power 2 equal to, again I am applying the same rule. So here x raised to the power log 10 to base 2 whole raised to the power 3. Now if you see, we have a common term x raised to the power log 10 to base 2. So I suppose x raised to the power log 10 to base 2 equal to m. So we get m plus m square equal to m cube. So this implies m cube minus m square minus m equal to 0. So this is a cubic equation. Now I can take m as common. This is m square minus m minus 1 in the bracket equal to 0. Now we have product of two factors here, which is equal to 0. So this implies either m equal to 0 or m square minus m minus 1 equal to 0. M equal to 0 or m square minus m minus 1 equal to 0. So we have got one value of m which is equal to 0. Now this is a quadratic equation, and we have to solve this quadratic equation for the value of m. m equal to 1 plus minus positive 1 and this is plus 4 over 2. So m equal to 1 plus minus root 5 over 2. So we have got two values of m here, which is 1 plus root 5 over 2, m equal to 1 minus root 5 over 2. Earlier we have got m equal to 0. So in total we have got three values of m. So let's take one by one. When m equal to 0, let's recall what we have supposed m earlier. M equal to x raised to the power log 10 to base 2. So we can write x raised to the power log 10 to base 2 equal to m. Now I will use common logarithm law, which says a raised to the power log b to base c equal to b raised to the power log a to base c. So we can write 10 raised to the power log x to base 2 equal to, now substituting the value of m here, which is equal to 0. Now to further simplify this, I suppose log x to base 2 equal to y. So this implies 10 raised to the power y equal to 0. Now if you see the equation, this will not hold true, as we cannot plug in any value of y, so that 10 raised to the power y will be equal to 0. So therefore this is rejected. Now let's take when m equal to 1 minus root 5 over 2. Since this value is less than 0, which means it is negative, and we have m equal to x raised to the power log 10 to base 2. So this implies x raised to the power log 10 to base 2 equal to 1 minus root 5 over 2. Again, I will use the common logarithm law, which says 10 raised to the power log x to base 2 equal to 1 minus root 5 over 2. To simplify further, I suppose log x to base 2 equal to z. So this implies 10 raised to the power z equal to 1 minus root 5 over 2. As we know that the right hand side is negative, which is less than 0, and the left hand side will remain positive for any value of z here. So we have a contradiction here. Therefore this 2 is rejected. Okay. Now take up case third, which is m equal to 1 plus root 5 over 2. this value is greater than 0. Now we have m equal to x raised to the power log 10 to base 2. So I can write x raised to the power log 10 to base 2 equal to 1 plus root 5 over 2. Again I will use the common logarithm property. So this will become 10 raised to the power log x to base 2 equal to 1 plus root 5 over 2. Now I am taking logarithm both sides. Now we have a property which says log a raised to the power b equal to b times log a. So I will apply this law on the left hand side. So I can write log x to base 2 times log 10 equal to log 1 plus root 5 over 2. So log x to base 2 times log 10 is 1 equal to log 1 plus root 5 over 2. So we get log x to base 2 equal to log 1 plus root 5 over 2. Now I will apply change of base rule, which says log a to base b equal to log a over log b. So I can write log x over log 2 equal to log 1 plus root 5 over 2. Now I will multiply both sides by log 2. Now log 2 will get cancelled out with log 2. So log x equal to log 2 times log 1 plus root 5 over 2. Now I will apply another property of log, which says b times log a equal to log a raised to the power b. So this log 2 will become the exponent. So I can write log x equal to log 1 plus root 5 over 2 whole raised to the power log 2. Now when log a is equal to log b, we can simply imply that A equal to B. So this implies x equal to 1 plus root 5 over 2 whole raised to the power log 2, and this is our final answer. So we have only one solution for x, which is equal to 1 plus root 5 over 2 whole raised to the power log 2. I hope you will like this video, and don't forget to like, share and subscribe. Thank you.